Hi students, today we are going to see assumption triangles first concept, right? Yesterday with the help of BPT, right, statement of BPT and converse of BPT, we have solved sums, right? We have solved sums. Today we are going to see proof, right? Proof based sums, right? Okay. So before entering to the sums, right? So first we have to recall the statement, right? Statement of BPT and converse of BPT, right? Statement of BPT and converse of BPT. So statement of BPT, basic proportionality theorem, is nothing but in a triangle, if a line is drawn parallel to any one side of a triangle, right? Any one side of a triangle, the remaining two sides divided in the same ratio, right? That is the statement of the BPT. Converse of BPT is nothing but vice versa. If the ratios are equal, then the two lines are parallel. Right? Same thing. So by using that, we are going to prove some proofs, right? So sum number 6, prove that, see, the sum number 6 is something but somewhat important, right? Somewhat very important in 2 marks, right? Sum number 6, prove that if ABCD is a trapezium, in which AB is parallel to DC parallel to EF, AB is parallel to DC parallel to EF, right? Then we want to prove that AE by ED is equal to BF by FC, right? So this is one type of question, right? The same question they will ask you in different word. That is something but any line parallel to parallel sides of a trapezium. See, any line parallel to parallel sides of a trapezium, right? Among the four sides, we are having that among the four sides of two side is something but what is that? Parallel sides, right? In a trapezium, two side will be parallel. For that, we want to draw a line parallel, right? Any line parallel to parallel sides of a trapezium divides the non-parallel sides proportionally. Divides the non-parallel. See, this is ABCD is a trapezium. Here AB and CD is nothing but parallel sides, and AD and BC are a non-parallel sides. AB and AD and BC are non-parallel sides. AD and BC are the non-parallel sides. When we are drawing a parallel line for the parallel sides, right, then it will be proportional. That is, non-parallel side will be proportional. That is, AE by ED is equal to BF by FC. So another words, so you have to understand the same question only, but they have given in the some different words, right? So you have to understand that. See, you have to understand that what we want to prove and what are the givens we have. In the given is nothing but AB is parallel to DC, parallel to EF, right? AB is parallel to DC at the same time parallel to EF also. And what we want to prove? We want to prove that AE by ED is equal to BF by FC, right? See, by using now we are going to use BPT only, right? By seeing the question itself, we are having that, what is it? If the clue word parallel came means, with the help of BPT statement, right? With the help of BPT statement, we are going to find or we are going to prove whatever they ask you to do, right? Right? But the statement is nothing but in a triangle, right? In a triangle, if a line is drawn. But here what we are having? We are having a trapezium. We don't have triangle, right? Here we are having a trapezium, right? We are having two trapeziums. See, not two trapeziums. We are having three trapeziums, right? A, B, C, D is nothing but one trapezium. A, B, F, E is nothing but one trapezium. E, F, C, D is nothing but one trapezium. We are having three trapeziums. But the statement is only applicable for triangle. So what we are doing means, we are doing a construction, right? Join AC. I'm just drawing the line AC, right? I'm just joining AC. Join AC which intersects EF at G. Join AC and intersect EF at G, right? Join AC which intersects EF at G, right? Now we got a triangle. How many triangles we are having? ADC is the one triangle. AEG is one triangle. What is it? We are having so many triangles, right? So here I'm just taking that in triangle ACD. I'm just taking the triangle ACD triangle, right? ACD triangle. EF is parallel to, EF is parallel to DC. EG is nothing but a part of EF, Therefore, EG is also parallel to DC, right? EG is also parallel to DC. Understood? See, we know that in the given EG is nothing but, right? See, EF is nothing but parallel to CD, right? EF is parallel to CD. EG is nothing but a part of EF, Therefore, EG is also what is it? Parallel to CD. So in triangle ACD, EG is parallel to DC, then by BPT, right? By BPT, AE by ED is equal to AG by GC. AE by ED is equal to AG by GC. Right? Take it as equation number 1. Next, I am just taking the triangle ABC. I'm just taking the triangle ABC. Here we are having that, what is that? GF is something but parallel to AB, right? GF, the line GF is something but parallel to AB. So by using the BPT, right, we can say that, what is it? AG by GC is equal to BF by FC. In triangle ABC, GF is parallel to AB. Therefore, AG by GC is equal to BF by FC by BPT. Equation number 2. Just compare the equation 1 and 2. See that AE by ED is equal to AG by GC. AG by GC is equal to BF by FC. Just compare equation 1 and 2. Here RHS and LHS are equal. If these two are equal, then we can say that AE by ED is equal to BF by FC. Shall we? AE by ED is equal to BF by FC. What we want to prove that? We want to prove that non-parallel sides are dividing in the same ratio, right? That is something but AE by ED is something but BF by FC, right? Hence it is. So number 7, in the given figure, right? In the given figure, if LM is parallel to LM, the line LM is parallel to BC, and LN is parallel to CD. We want to prove that AM by AB whole part, right? AM by AB is equal to AN by AD. We want to prove that AM by AB is equal to AN by AD. So by seeing the diagram from the given itself, we can come to the conclusion how we are going to prove. We are going to prove with the help of BPT statement, right? So BPT statement, because in triangle ABC, right, LM is parallel to BC, then directly we can say that AM by MB is equal to AL by LC. And second triangle, I'm just taking that ADC, right, in triangle ADC, what is it? LN is parallel to CD is given, right? Given LN is parallel to CD. So by BPT, AL by LC is equal to AN by ND, right? AL by LC is equal to AN by ND. So here, what is it? For both the triangle, which side is common? AL by LC is common. So AL by, say from the equation 1 and 2, right? From this equation 1 and 2, we can say that AL by LC is equal. Then we can say that AM by MB is equal to AN by ND. But here what they ask you to prove, AM by, not MB, AM by AB. That's very important. AM by AB is equal to AN by AD, right? So AM is something but a part of the whole part, right? AM is something but a part of AB, right? A part of AB. So here we want to, already we have discussed that when we are finding the whole part, right, when we are going to find the whole part, how we will find? By using +1, right? By adding +1, we will find it, right? Same like that, right? So here I'm just taking the first triangle, right? In the given LM parallel to BC and LN parallel to CD, what we want to prove? AM by AB is equal to AN by AD, right? So proof, in triangle ABC, I'm just taking the first triangle. In triangle ABC, what is it? LM is parallel to BC. LM is parallel to the line LM is parallel to side BC. Then what is it? By using BPT, we can say that, what is it? AM by MB is equal to AL by LC. AM by MB, right? AM by MB is equal to AL by LC, right? So, but what we want to find, see just see the proof. What we are needed? AM is needed, right? AM by AB, right? So here AB, so we want to convert this a part into the whole. So I want to add +1. Before that, what I am needed? AM by AB. So AM is needed. So that part alone we want to keep it in the denominator, right? So for that, I am just doing reciprocal on both sides, right? Then it will become, what is it? MB by AM is equal to LC by AL. Now you can adding 1 on both sides, right? +1, and just do the cross multiply. Then it will become, what is it? MB plus AM divided by AM is equal to LC plus AL whole divided by AL, right? So MB plus AM, what is MB plus AM? MB plus AM is nothing but AB, right? MB plus AM is nothing but AB. Same thing like, what is it? AL plus LC is nothing but AC. So I'm just converting MB plus AM is nothing but AB. AB by AM is equal to, what is it? LC plus AC is nothing but AC, right? AC divided by AL, AC by AL, right? See that in the proof what we are having AM by AB, but here what we are having AB by AM. So once again what I am doing, reciprocating on both sides, so it will become, what is it? AM by AB is equal to AL by AC. Take it as equation number 1, right? Again I am doing the same process, right? I am just taking the second triangle, right? And now I am going to take the second triangle. In triangle ACD, right, they have given that LN, the line LN is parallel to the third side CD, right? Third side CD, right? So LN is parallel to CD. By using BPT, what is it? AL by LC is equal to AN by ND, right? So what we are having, AN by ND, AN by AD. So whole part. So here also I am going to add plus 1. Same process. First I am just reciprocating because I need the AN. So I'm just keeping that, what is it? I'm just reciprocating on both sides. So LC by AL is equal to ND by AN. Adding 1 on both sides. Then LC by AL plus 1. Just do the cross multiply. It is nothing but LC plus AL whole divided by AL is equal to ND by AN plus 1. Just do the cross multiply. ND plus AN divided by AL. LC plus AL. Just see the diagram. LC plus AL is nothing but AC divided by AL, and ND plus AN is nothing but AD divided by AN, right? See that, but what, see the proof, what we want to prove, AN by AD only we are needed. So just doing the reciprocal on both sides. So AL by AC is equal to AN by AD. Just compare from equation 1 and 2. We are having that LHS and the LHS of equation 2 and RHS of equation 1 are equal. So from equation 1 and 2, AM by AB is equal to AN by AD. Hence it is. Understood? So by seeing the proof, right? By seeing the proof, what we want to prove, from there itself you just come to the conclusion how we are going to prove, right? From there itself you just come to the conclusion how we are going to prove, by which methodology we are going to prove, right? Next, sum number 9. Sorry, sum number 8, right? 7 completed. Sum number 8, see. The given figure DE, right? DE is parallel to OQ. DE is parallel to OQ. And DF is parallel to OR. DF is parallel to OR. Show that EF is parallel to QR. So that EF is parallel to QR. So here we want to prove that. So usually in the sum number 6 and sum number 7 and all, we have proved that ratios are equal. But here what we want to prove? We want to prove EF is parallel to QR. That is named converse of BPT, right? We want to prove that the two lines are parallel. That is converse of BPT. So that means first we have to prove that, right? But with the help of the given, we have to prove that PE by EQ is equal to PF by FR. PF by FR. If the sides are proportional, the sides are proportional, right, are in the same ratio, then we can say that when the PE by EQ is equal to PF by FR, when EF is parallel to QR. Understood? So we want to prove that PE by EQ is equal to PF by FR first. So we are having some givens. What is it? D is parallel to OQ. DE is nothing but parallel to OQ. So I'm just taking the triangle POQ, right? In triangle POQ, DE is, right? DE is parallel to OQ. DE is parallel to OQ. Then PE by EQ is equal to PD by DO. PD by DO by BPT. Taking this equation number 1. Next I'm just taking the second triangle POR, right? In triangle POR, right? Here DF is parallel to OR. This is given, right? DF is parallel to OR. So by BPT, PD by DO is equal to PF by FR. PD by DO is equal to PF by FR. Take it as equation number 2. Just compare equation 1 and 2. PD by DO, right? Both are equal. If these two are equal, then we can say that PE by EQ is equal to PF by FR. PE by EQ is equal to PF by FR. When these two are equal, right? When the ratios are equal, when it will be equal? When the two lines are parallel. Which two lines? EF is parallel to QR. That alone we want to prove. So therefore, EF is parallel to QR by converse of BPT. Hence, it is. Right? Next is sum number 9. See, actually the triangle chapter is very easy, but you have to understand the property, right? You have to understand the property and you have to apply properly. You have to, you have to analyze and which and all parallel and which triangle, right? You have to understand properly and you have to apply, right? You have to apply correctly. Then whatever they are asking, we will do that. We will find it, right? Sum number 9. In the given figure, AB is parallel to DE. AB is parallel to DE, right? AB is parallel to DE. At the same time, BD, right? BD is parallel to FE. Parallel to FE. Prove that DC square is equal to CF into AC. DC square is equal to CF into AC. So how we are going to prove? See, very simple. When you are seeing the proof, right? This is somewhat different actually. How we have saw the sums like what is it? How and all we have proved? We have proved that same ratios or it will be parallel, right? The two lines are parallel. Likewise only we have proved, right? But here somewhat different. DC square is equal to like some squares and multiplication and all coming. How we are going to prove? See, this is very easy only, right? So you have to analyze how we are going to prove means. See, DC square is something but we can write it as DC into DC is equal to CF into AC, right? See that you just we are having terms of multiply, right? So how it will be multiplied? When it is in the form of fraction, when we are taking to the LHS and RHS, then only it will become multiply. I'm just bringing the CF to the LHS. So DC by CF is equal to AC by DC. Or, right, DC divided by AC, right? I'm just bringing this AC to the LHS, it will become divide, right? And CF by AC. So we have to prove like this way and automatically we'll get this solution. DC square is equal to CF into AC, right? So if we are having that, we are having some given, right, parallel sides, right? So with the help of the given, by using the BPT, I am just going to prove in this format. After getting this format, I am just going to multiply and we'll get this DC square is equal to CF into AC, right? So first see the diagram, how we are going to find, right? How we are going to prove and which are the triangles we want to take. By seeing the triangle itself, diagram itself, by seeing the diagram itself, we have to come to the conclusion how and all we are going to prove, right? What are the triangles we want to choose and how and all we are going to prove. In the given figure, AB is already we have discussed, right? So given AB is parallel to DE and BD is parallel to FE, right? BD is parallel to FE or EF, and we want to prove that DC square equal to CF into AC. First I am just choosing the triangle in CDB triangle, right? In triangle CDB. Why I am just choosing this triangle means they have given that EF is parallel to DB, right? So otherwise you can take the triangle ABC, whatever it may be, no problem, right? So whatever it may be. See, before that, DC is nothing but, right? DC, CF and AC, right? DC, CF and AC. DC is nothing but a part or whole of a triangle BCD. In triangle BCD, DC is nothing but whole part, right? Not a part of a triangle, whole part, full side, right? Full side. So full side means how we will find using adding +1 on both sides. By using that method only we want to prove, right? Same thing, CF is nothing but a part. CF is nothing but a part of a side of a triangle, but AC is nothing but whole part, right? AC is nothing but whole part. So +1, we want to add +1. By using that method alone, we are going to find. So by seeing the proof itself, right? By seeing the proof itself, we are coming to the conclusion how we are going to prove. So first time we are just taking the triangle CDB, right? CDB. In triangle CDB, FE is parallel to DB. FE is parallel to DB or BD, right? So by using BPT, what is it? CF by FD is equal to CE by EB. CF by FD is equal to CE by EB, right? So see that what we are needed. CF alone we are needed. So the CF alone we want to keep it in the denominator. Then only it will be remain same, right? So for that I am just taking reciprocal. So FD by CF is equal to EB by CE. Adding 1 on both sides, then FD by CF plus 1 is equal to EB by CE plus 1. To the cross multiplication. So FD plus CF divided by CF is equal to EB plus CE divided by CE, right? Now FD plus CE is nothing but CF is nothing but FD plus CF is nothing but CD, right? So CD divided by CD or DC divided by CF is equal to EB plus CE is nothing but BC by CE. Right, take it as equation number 1. Next, again in triangle ABC, now I am just taking the full triangle. In this triangle, which two are parallel? DE is parallel to ABC. In triangle ABC, DE is parallel to AB, right? So DE is parallel to AB, then we can say that CD by DA is equal to CE by EB. That only I am just writing. CD by DA is equal to CE by EB, right? Here what we are needed? We are needed, what is it? See, we want to keep the CE alone, the CE alone remains same. We want to keep CE alone. So I'm just keeping the CE in the denominator. So for that, I'm just taking reciprocaling on both sides. So DA by CD is equal to EB by CE. Once again, adding one on both sides. Why I'm just adding one on both sides? We want to convert into the whole, right? A part into the whole. That is nothing but DA by CD plus 1 is equal to EB by CE plus 1. So just do the cross multiply. DA plus CD whole divided by CD is equal to EB plus CE divided by CE, right? What is DA plus CD? Something but AC divided by CD is equal to EB plus CE is something but BC by CE. Take this equation number 2. Just compare equation 1 and 2. Equation 1 is something but DC by CF is equal to BC by CE. AC by DC is equal to BC by CE. Both the RHS are equal. If both the RHS are equal, then we can equate the LHS. That is DC by CF is equal to AC by DC. From equation 1 and 2, DC by CF is equal to AC by DC. Just do the cross multiply. DC into DC is equal to AC into CF. DC into DC is nothing but DC square is equal to AC into CF. Hence it is. Understood? Easy. And today homework is nothing but this all the 4 sums, right? Once if you are completing your classwork, take the rough note, just write down all the 4 questions, right? And without saying, right? Without saying or without referring, you just solve once again, right? And this is your homework today, right? Thank you.